have quadrilaterals now, any polygon, then what we are relying on is the sides are in the same proportion to each other and the angles are congruent. So if we look at these, kind of similar to what I did with Alexis, we'll use 7 again since that's Alexis's favorite number. What did these all have to be 7? If we go to the other polygon, don't those also have to have, since they're all marked with the same one tick mark, those are also all 7. So in terms of the sides, we're definitely good with the sides because the sides would all be 7 to 7, 7 to 7, 7 to 7, 7 to 7. So those obviously are the same ratio. They're 1-to-1 ratio. But the other item that has to be true is all of the angles need to be congruent. So when we look at this one, these are all 90-degree angles. When we look at this one, if this angle is congruent to this angle only, and then if we look at the other two angles, this angle is congruent to this angle. What that means is if these were all 90-degree angles, oh, I thought that was the overhead there, that motorcycle. If these are all the same angles, wouldn't they all be marked the same way? So since these are not all congruent and then these are, there's no way that between these two different shapes that they're congruent. So this is one, when it says decide whether these are similar, we would say no, they're not. All right, they don't have congruent corresponding angles everywhere. All right, so we don't have to worry about then writing a similarity statement. We don't have to worry about giving that similarity ratio. All right, go to letter B. Let's see where we're at. Try letter B real quick. And we'll see if the same thing happens in this period that happened first period. All right. This one should be hard to mess up. Very hard. Here are our three options: angle, angle similarity, side, side, side similarity, side, angle, side similarity. All right. Jake, what did you do, Jake? All right. Did everybody do side, side, side? No? Because first period, everybody did side, side, side. So let's say we do side, side, side. All right, good. Yeah, that's what happened first period. So let's take the longest side, the 12, and let's compare it to our longest side over here, which is 9. What'd you get that to be, Jake? 1.3. Good. So he used his calculator. That's 1.3 repeating. If you just reduce it 4/3, that's also okay. The decimal or the fraction answer is fine. All right. So then if we go from we'll go from the 1 arc to the double arc. So that's an 8 in the big triangle. If I go from the 1 arc to the double arc, that's a 6. Did you get the same thing, Jake? Yeah. Yeah, we get 1.3 again repeating. The only thing left over then is to compare the 6 with the 4.5. Does that give us the same stuff, Jake? All right. So we've just shown that all three sides have the same ratio to each other. So absolutely, side, side, side similarity is correct. However, we could definitely do this with absolutely no work. How'd you do it, Mason?
I just looked at the angles or whatever.
Good. Mason looked at the angles or whatever, and she saw that this has 1 arc. Let's look at the other triangle. Doesn't that have 1 arc? So don't we know those are congruent? And then don't we know that this angle is congruent to this angle? So don't we have 2 corresponding angles right from the get-go without having to do any work at all? So we could have just said angle similarity as well. So that's an acceptable answer for this one. And then if we know all the sides are in the same ratio and we know all the angles are then congruent, there's really nothing stopping us from saying this one as well, which is why this one is really hard to mess up. All right, there's enough markings there to justify all three of those. Okay. Now we want to do two things, write our similarity statement. So do that real quick. Hopefully we were getting that down pat. All right, and Brooke back there. What did you put for the first one, Brooke?
I did angle OPT.
Say that one more time.
OPT.
Ooh, Brooke's gonna really throw us off here. She's gonna use this one first, so totally fine. So O, P to T. So she went from the unmarked angle to the double marked angle to the single marked angle. So what's that over here gonna look like, Brooke?
NML.
Good. NML, from the unmarked angle to the double marked angle to the single marked angle. I'm kind of liking that because I'm guessing a lot of you didn't do it that way. So then you just now have to look on your own. Does the O match up with the N? Does your P match up with M? And does T match up with L? And if it does, then you're good. All right, your order is fine. Okay, good. All right, letter C. Not a triangle, so we can't do the whole angle, side, side, all that good stuff. What we're looking at is, do the sides, well, the angles are easy, right? Yeah, we definitely know that all of those are congruent, but angle doesn't work unless it's triangles. So don't just assume that since two of those are congruent, that's going to be okay. What also has to be true is their sides need to have the same ratio. So 10 to 8, pretty obvious. We're going to do the 10 to the 8 here. They have a ratio of 5/4. Or if you like the decimals, Jake gave us a decimal, that's okay too. It's either that fraction reduced or the decimal 1.25. Compare the other corresponding sides. So we'll do the base. Does this 6/4, is that going to give us the exact same fraction or decimal? So if I reduce this to be 3/2, does that give you 1.25? Good, gives you 1.5. So do their sides match up in the same ratio? No. All right, so we don't have to worry about that one. So this is a no. All right, and then letter D, last one. Triangles. So the triangles we have done plenty of. Do that one real quick. Okay, in terms of the theorem, again, we in general want to do as little work as possible and still end up with a good result. So all the sides are marked, and it's easy to identify all the sides are marked, so that's why I think people like to do side, side, side. If you do side, 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 did they all work? Maybe do side, side, make them all work. Yeah, they all would have worked. But in an effort to do as little work as possible, don't we have one set of angles that are congruent? They're both 90 degrees. And then you were told that this angle is congruent to this angle right here. So without having to do any work, we can make the statement that through angle similarity, those triangles are similar. All right, because we have two sets of corresponding angles that are congruent. Side, side, side is totally fine. All of these, if we would have done this, we need to kind of do it anyway here. Oh, I haven't been writing that. For our similarity ratio, we can definitely do that if you did like 9 to 6, 12 to 8, 15 to 10, those all reduce down to be 3 halves. So that's why side, side, side would work. And then if we're going to do our triangle similarity statements, do we have that yet? You got it yet, Gael? Okay, write your triangle, your similarity statement real quick. However you see it. All right, Ahmad, what you got, Ahmad? All right, so Ahmad went X, A, R. So he went the unmarked angle to the 90-degree angle to this marked angle. So over here, that would look like what, Ahmad? Good, M and T. All right. The ratio is this 3 halves. That's the ratio from one to the other. All right, that's our answer. All right, so now let's go to this next one. You're given what is now, we don't have triangles. You're given parallelograms. So this symbol in front of it just means these are parallelograms. So remember what that means. That means this side is parallel to that side. So these guys, these sides are parallel. Opposite sides are parallel and opposite sides are congruent. So if I know that this is 6, don't we know that that's 6? And if I know that this side is 3, we know that this side is 3. The other one is also a parallelogram. So I know if this is 2, the opposite side is 2. So we can get all that right away. Do A and B. Do both A and B. Both are asking you to find the scale factor. So that's just the ratio between these two figures. So same exact question, but also very much different. So read A, read B. See if you understand how they're both similar, yet you're going to get some different answers for them. All right, so try A and B. See what we think. All right, your scale factor is just your ratio between these two. So if we look at this, the ones that you were given, we now know a little more information, but the sides that were flat out given to you were these guys, that we had 3 on the right-hand side, we had a 2 on the right-hand side. Both of these are asking for the scale factor, but now just kind of understand what this means. We want to go RSTU to LMNO. So we're going to go from this one down to this one. So when we set this up, the side that we knew, the corresponding side we knew up here would have been a 3 in that parallelogram. And then the corresponding side down here would be a 2. So 3 to 2. You can absolutely write that as a fraction as well, 3 to 2. When you go to the next one, it's asking largely the exact same thing, except we now want to go from LMNO. So we're now reversing this. We want to take this as the initial, and then we create this one. We go to the bigger one. So now the smaller side, or the smaller side, or the side on the smaller parallelogram is 2, and we're comparing that to the bigger one, which is 3. That then could get written as a fraction 2/3. So same thing, but we just want to know the order, and we want to have the correct order. If I now ask you to find letter C, so now understand what this is asking you to do. This is what Victoria did yesterday. We could set up a proportion, and I will set up a proportion in a minute. But what the scale factor is telling you is that the smaller parallelogram those sides will always be 2/3 the length of the bigger ones. So if I want this one right here, which I do, that's this question right now, this side should be 2/3 the size of 6, since that's our scale factor. It's always 2/3 that side. So what we could do, and this is what she did yesterday, is take that scale factor and just multiply the bigger one by 2/3. I know my new length has to be 2/3 of the big one. If you did that, this little product is going to give you a 4, and that's the correct answer. So that's a different way of kind of thinking it, and that's kind of what she did. We can absolutely set up a proportion, though. So if you're not sure what we just talked about, and you don't want to deal with that in the future, you could definitely go 3/2 would equal, and I mean, I'll get rid of this, the side of 6 over the side that we're looking for of x, and we can set up a proportion. The proportions would still work for other figures as well. Cross multiply, we would get 3x equals 12. When I divide that, isn't that going to get me the same number that we got by just multiplying by the scale factor? Okay. All right, real quick, a measure of angle. You remember in a parallelogram, which these are, consecutive angles are supplementary. So if this is 125, if I did 180 minus 125, that leaves me with 55. So this angle has to be 55 degrees. The reason we want to know that angle is because if you go up to angle U, the one that it's asking about, those are corresponding angles, must also be 55. Angles are congruent. So that's 55. All right, and then real quick, what I really wanted to get at, make sure we discuss this again, this last couple things. Find the perimeter of L, M, and O. So that's the smaller parallelogram. So go to the smaller parallelogram. Erase everything that we don't need. We had already found that this was, come on, 4. All right, that was the answer right here. So that means this side is 4. So add up all those sides. And the perimeter of the small one was a 12. So that's our perimeter. Put a 12 in here. To answer letter F, find the perimeter of the big one. So let's just do 6 plus 6 would have been 12. 12 plus 3 is 15. 15 plus 3 is 18. So the perimeter of the big one was 18. The perimeter of the small one was 12. Because what F is then asking you to do is find the ratio between those, between the perimeters. So now let's take those two perimeters, although your F is, so is mine. Take those two perimeters. Didn't we find RSTU to be 18? We're going to compare that to the perimeter of LMNO, which is 12. So let's write this as a fraction. If I reduce that, divide each of those by a 6, and I would get 3:2. Isn't that the same ratio that we got earlier when we were doing the sides? Yeah. So what we want to understand is the perimeters will have the exact same ratio as the ratio of those sides have, as long as we have similar whatever. In this case, it was a parallelogram. All right, so any polygon, that's going to be true. Okay. All right. We didn't get to this. It's just kind of more of the same. We answer that same exact question, find the ratio of the perimeters. Whatever the ratio would have been of the sides, the ratio of the perimeters are going to be identical. You don't even really have to do the work. So once we can identify what those were, then it's going to be the side. Actually, let's do that real quick. The scale factor with this, let's go 10 to, here's our corresponding sides, the 10 to the 15. We'll do the opposite of the right angle. So that's 10 to 15, or I'm sorry, 10 to 25. Reduce that down to be 2/5. So the small triangle is always 2/5 the size of the big one. And then in letter D, we could do all the work for it, but guaranteed their ratios for the perimeter are also going to be 2 to 5. All right, the perimeter of the small one will be 2/5 the size of the big one. All right, so with that, and that's sort of what this is. You do have homework for tomorrow night, so that's just going to be the next page. I think it's pretty quick, both of them. So if you haven't gotten the original one done, get that for tonight, and then try to make sure that this one gets done for tomorrow night. If we have questions on this one, we can talk about it in the morning. Okay? All right. We got less than a minute, so at home, you guys can check out. All right, have a good day, and we'll see you tomorrow. Who do you play? Who do they play?
Who did I call Bolingbrook?
Bolingbrook? Home or what?
It's all.
Okay, good. Nice stop in there. See you guys. Have a good day. Thanks, Mod. You too.